Welcome to Pre-Calculus Homework, Chapter 1, numbers 23 through 29. We're starting with a little math note called argument of a function. The argument of a function is the expression that is being acted upon. Another word for it is input. The input of the function. So, for example, when we're looking at this function here, the x minus 1 is the function, is the input. When looking at this function here, the x plus 7 is the input or the argument. And in function notation, in f of x, x is the input or the argument, and in f of 3b, 3b is the argument. So 23, very, very simple. All you need to do is state what the argument is of each of these functions. So, looking at A, the input to what's basically what is being cubed is the x plus 2. So that is the argument. So you guys do B and C. D is a little interesting. Sometimes we put parentheses, but it's basically the sign of what? Well, the sign of 5x. So you do B and C on your own. Moving on. Okay, so this is kind of testing that out. Suppose this is our function right here. Find each of these. So 4 is the argument in this case. So f of 4 means we plug in or substitute 4 in place of the x. And then simplify. So you go ahead and simplify. Same thing with this one. Do B front to end all by yourself. On C, you are plugging in place of the x 3b. So it ends up being 2 times 3b squared minus 3. So the next step is to simplify this. So you have to square the 3, square the b, multiply this by 2, and simplify. So continue simplifying to get the rest of this. So on D, same thing. Our argument is a plus 1. So we're going to need to plug in a plus 1 in place of the x in our function. That's where that goes. So it's a plus 1 squared minus 3. So in simplifying this, simplifying all of these really, you need to remember order of operations. And order of operations says that we're going to do parentheses. That means inside the parentheses. So a plus 1, nope, can't do that. Exponents. We can do the exponents. We need to do a plus 1 squared. Well, what does that mean? It means to multiply a plus 1 times a plus 1. And FOIL, boxes, whatever, we end up with a squared plus 2a plus 1. And all of that is what we got from this part right here. So all of that is still multiplied by 2, and then at the very end, subtract 3. So multiply all that by 2 by distributing the 2. 2a squared plus 4a plus 2. Then subtract 3. Final step, combine like terms, which are these two here. 2a squared plus 4a minus 1. And that's the final result. So thinking about D, explain in number 25 why these are not equal. These are definitely not equal. You can't just square this and square this. So it has something to do with this step that we did right here. This means multiply each of these by each other. So then find the correct expansion. This means you have to do this correctly. Okay, so I'm going to leave that one to do on your own, please. All right, another little set of math notes. This is a nice review of our exponent rules. These are rules that you should know. You've learned them before, but we are going to review them. So we've got rule number 1 where it says we've got the same base, x and x. X minus, now this I think is a typo. This is supposed to say times. I don't know why that says minus. Let me check in my book and see how that compares. Yes, this is a typo. This is supposed to say multiply. So when we're doing x to the m power times x to the n power, it's m x's multiplied together with n x's. So the shortcut is to add those. In this one, it's division. The shortcut being to subtract. In this one, it's raising a power to a power. And that one is always to multiply, m times n. Those three are the ones that are most commonly used. This one is used sometimes, quite useful. If you've got two numbers next to each other, both raised to some power, you need to raise each of them separately to the power. And this frequently comes up in the example of where we have 3b to the power of 2. We need to square the 3 and square the b, so our result ends up being 9b squared. That's a great example of that rule. And here, if these are divided, then each of them separately is raised to the power of n. Same kind of thing. So using all of those rules, you're going to do the next several problems. So simplify using these, or state why it cannot be simplified. Okay, so a, first of all, it needs to have the same base. So these each have a base of a. So we can simplify this with the same base a using rule number 1. And we end up with b plus c as the exponent, and that's it. Okay, so use that same logic there and do b, still rule number 1. On this one, c, is this one of our rules? Is there an adding? Nope, this one cannot be simplified. Cannot be simplified. These are not like terms. A to the b power is not a like term with a to the c power, so we cannot simplify. In this one, do we have the same base? Yes. It's a multiply, so it's rule number 1. What's the exponent on this? Well, the exponent is 1. So we can apply the rule, a to the b plus 1. Alright, using the same logic and the same rule, finish E. And on F, same rule again. We've got a base of A, and all of these can add together, so 2 C's together, so we end up with 3C plus B when we combine like terms. Moving on to the next one. Okay, factor completely. So we're looking for the greatest common factor in all of the terms. So this one, very much like what we did in the last homework set, so I'm going to have you do that on your own. This one, we're looking for a common argument, basically. A common piece that's in the parentheses. So I see here that this piece is the exact same as this piece. So I'm going to divide this out of each term. Like this. Now, you don't have to write it all out like this, but it's a way to think about it. So, basically 2x plus 1 times what's left here is 3. And what's left here is x plus 5. Oops, 5, that's what I meant. It's a set of parentheses. So that's the basic. At this point, we could actually combine the 3 and the 5 here, because that would be okay to do according to rules. Alright, so using that same logic, how could we do that with C and with D? You work on C on your own. I'm going to go ahead and work out D. I see an x plus y and an x plus y that can be factored out. So I factor out an x plus y. Think of that as one input or one number. It just looks larger because it's got two terms. And what's left is m and a plus and an x plus y. So that's what that looks like. Alright, the last two. So simplifying using the rules. This looks like rule number 4 to me. We need to raise, it's actually a combination. We need to raise this and this to the power of 2. So 5 to the power of 2 is 25. And a to the negative 2 power to the raised to the power of 2, we multiply those together. A power raised to a power is multiply. So that's the result. Okay, use the same strategy to do B. Raise this to the power of 3 by multiplying, raise this to the power of 3 by multiplying. Alright, this one. Let's look at this piece to start with. This is 2 times x to the 0 power. Is the 0 power affecting the 2 or just the x? Just the x. So this basically means 2 times 1. Anything to the power of 0 is 1. So this basically means 2. So in the end of all of this, we're going to multiply by 2. So I'm going to go ahead and put that out in front. Now I'm going to work on this piece. This piece here says raise 2 to the power of 2, which gives me a 4. And x to the power of negative 1 raised to the power of 2 gives me a power of negative 2. And multiply all of this by 2, and we end up with 8x to the power of negative 2. Okay, simplify each expression using the rules of exponents. Alright, so we've got this one, you go ahead and do those on your own. Now this one, what does the negative exponent mean? Reciprocal. Yes, so I can do 3x, and that's that one. Well, this one, it's a combination of two rules, both reciprocal, so we're going to flip over 3 over 2 to take care of the negative. And then both of these are then raised to the power of 2, so it's 3 squared over 2 squared, which gives me 9 over 4. And we could have done that up here, but we don't need to. Unless it says to leave your answers with no negative exponents, then you don't really need to. But if that was the case, I could do one more step and do the reciprocal of x to the negative 2, which would leave that as 8 times 1 over x squared, and it would turn out as 8 over x squared. And this is equivalent to what we got here. Okay, that's it for the homework. Be sure to watch the other video on inverse and operations of functions.